Okay, welcome to whole number multiplication. We're actually going to look at multiplication models. There's lots of other aspects of multiplication. You could spend a whole year in the class talking about how you teach multiplication, but this is just one little snapshot of some important things related to multiplication. We're going to have four different models, but there's really an overarching model of multiplication that involves groups of. That we understand that we're making groups of all the same size, and those groups are making up this whole in some sense. And so all the way through here we're going to be using groups of language, but we're going to look at different kinds of models inside that. So there's this really big model that's a groups of kind of thing. We will look at, in class, we'll get a bead frame out to show how you can develop that groups of language initially, but keep in mind groups of all the way through here. So the first model of multiplication is called repeated addition. If we're doing it for a 5 times 3 problem, if I had asked you to write down what that would look like in terms of repeated addition, a lot of people would have put down 3 plus 3 plus 3 plus 3 plus 3, and that's good. And if you go back to the groups of language, that really is 5 groups of 3. That little times in that little X should stand for groups of, but you'll see how we develop that in class. But note that even though you know that 5 plus 5 plus 5 is also 15, that is not really a model for 5 times 3, because 5 times 3 is 5 groups of 3, and if we do 5 plus 5 plus 5, that's 3 groups of 5. So we're going to do a lot of stuff with multiplication where you have to really pay close attention to the order that you use, because the order means something different conceptually. So we will focus on that as we go through also. But repeated addition, just change it into a string of additions. Second way, sometimes textbooks leave out everything except that repeated addition one. But the second one that you'll see in a lot of new textbooks is called an array. An array is called a discrete model, and we'll contrast that with a third one here in just a second. But it's just a rectangular arrangement of objects. So notice that you've got 5 rows with 3 in each row, or you can look at it as 3 rows with 5 in each row. So it's just a 5 by 3 array. And the little or question mark means there, do you notice that I could have rotated it 90 degrees? And if you looked at it as 3 rows with 5 in each row before, when you rotate it 90 degrees, now you see it as 5 rows with 3 in each row. And so there's a lot of power with seeing that in both directions, from both perspectives when you're doing an array. We'll also discuss that in class, how that leads to understanding of commutativity with multiplication. Third model is very closely related to the array, but it's a rectangular area model. It's just a rectangle where the dimensions are 3 by 5 if we're trying to model 3 times 5 or 5 times 3. Notice that bottom row of that rectangle has 5 units in it, and that 5 units are stacked up 3 times, and so you can really see the 5 plus 5 plus 5 related to that. Or if you turn it 90 degrees, you can see 3 in the bottom layer and then 5 layers just like that, so you can see the 3 plus 3 plus 3 plus 3 plus 3, or the 5 groups of 3. So again, just like the array, this can easily be seen from 2 different perspectives, so that the order doesn't matter quite so much on rectangular area or array, because both perspectives are just as obvious. We will spend some time in class sorting that out in just a little bit more detail too. So the idea on this is why this is a model, because we want kids, when they see a problem involving area of a rectangle, they should know that that's multiplicative. And so that's why it's one of the models of multiplication that we use. Fourth one's a little bit more obscure. Sometimes you'll see this in textbooks, but a lot of people have actually never seen the cross product model of multiplication. In this case, the model is really a word problem situation that again is multiplicative. If you have 3 shirts and 5 pairs of pants, how many different outfits can you make? Well, it turns out if you can do a tree diagram of that, and we've hopefully talked about that in class, what a tree diagram looks like, that you can do the tree diagram and actually see the multiplicative nature, that there are really five different outfits that you can make with with each shirt. You know, shirt 1, you've got 5 different pairs of pants you can do it, so there's 5 different outfits with shirt 1 and 5 with shirt 2 and 5 with shirt 3. So we want kids to see a situation like this and know that it is multiplicative. We will also in class probably do some other things with looking at pairing cards. Cross product is really making pairs out of 2 different lists, making a pair and then seeing how many pairs you can make. But we will sort that out in class to talk about why it's called cross product, also a little bit of history about why it's called Cartesian. So you can be thinking about, where does that word Cartesian come from? Have you seen that anywhere else? We will mention that in class probably, though, so you'll see what the connection is there. So typically those are the 4 models of whole number multiplication. If you look in textbooks or even look in most of the literature about multiplication, you will find those 4. However, there is a 5th one that really probably ought to be listed, and I'm going to make the argument here that this is the most elementary model of multiplication. It's where you ought to start. That kids, you just don't start with kids with repeated addition, because it's an abstraction. It's involving taking that 5 times 3 and seeing it as 3 plus 3 plus 3 plus 3 plus 3. That's an abstraction using symbols. But kids are used to counting in the context of addition. They build their multiplication concepts on what they already know how to do with addition. And the number sequence that they already know how to count. They may have done some activities where they pull out 2 objects at a time or 3 objects at a time and count by 2s or count by 3s. But the counting activity is a nice natural progression from their addition strategy. So the situation of 5 times 3, 5 groups, 5 pockets, 3 pennies in each one. How many total pennies? A child who is building on their addition concepts is going to probably do something like this. They maybe even double count with their fingers. 1, 2, 3, and hold up one finger. That's the first group of 3. 4, 5, 6, hold up another finger. 7, 8, 9, hold up another finger, etc., all the way to the end. Sometimes I'll just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you see how they're using their number sequence and just segmenting up into groups of 3 and keeping track of those segments that they made. Sometimes if the kid knows their skip counting by 3s, they might just say 3, 6, 9, and maybe if they're stuck, then they might say 10, 11, 12, hold up another finger, 13, 14, 15, hold up another finger. So there's lots of ways they could do this depending on how powerful their number sequence is. But I'd want to argue that this is basic. This is where you start with kids. You don't start with that abstract repeated addition thing that most textbooks will say kids are supposed to do when they do multiplication. Build on what they already know from addition. So 5 different models there. Here's a couple of notes, and these are really just notes to let you know what's going to happen in class, what's coming up. We will talk a little bit about this, but repeated addition and counting activity are really not good models to help develop commutativity. Even though the counting activity is important, it doesn't lend itself to kids understanding commutativity, that 5 groups of 3 is going to give me the same answer as 3 groups of 5. That just doesn't happen, and we'll model that in class so you can see how counting or repeated addition doesn't help. However, commutative property is really clear. We kind of mentioned it already with both the array and the area model, because all you have to do is rotate it 90 degrees or just change perspective, look at it from the other perspective, and the 5 groups of 3 become 3 groups of 5 right in front of you. And so it's a really nice way to understand commutativity. Now, here's the point. If you want kids to do commutativity and have that power to know that I can change the order of a product, you're not going to develop that well if all you teach them is repeated addition model. Many books only teach repeated addition and model, and so you're stuck then with telling kids this math is a religion kind of rule thing, that 3 times 5 is the same as 5 times 3. And they just have to trust you and believe you because you said it. But if you've developed models of multiplication involving the array and area model, it's really clear to them. They will understand why the commutative property works, why I can change the order. It's just a change of perspective is all that's involved. Also, commutativity is kind of a stretch with cross product. But it turns out, and we'll see this in class, that there's a relationship between cross product and array. So I can get to the commutativity in the cross product model by going through the array that fits with the cross-product situation. But generally, it's kind of hard to see commutativity with the cross-product. I mean, three shirts and 5 pairs of pants makes 15 outfits, but five shirts and 3 pairs of pants, that also makes 15. But it isn't clear that we've commuted things there in a straightforward way. We will also look at in class how adult-oriented texts sometimes deal with models of multiplication. So we'll get to look at what things to be aware of and watch for when you're trying to develop this from textbooks that you have. And we'll also look at, in the same context, the way some adult-oriented texts deal with other properties involving multiplication, zero product, associativity, identity property, and some of those. We'll look at a different way of making sense of those that isn't quite so adult, rule-oriented, symbol manipulation-oriented kind of approach to those properties of real numbers. So here's the assignment that you need to bring to the next class period. It's really just a summary of what we just did here. List the 5 models of multiplication and a representation of each of those models to fit 4 times 5. So give me the title, show how that representation fits in that particular category, but make it fit 4 times 5. And notice, I'll give you a hint, that should say 4 groups of 5. So make sure your model fits 4 groups of 5 if it makes a difference. And then just a little bit of work on the cross-product thing. If we have 3 shirts and 5 pairs of pants, can you make a tree diagram to model that? And we'll check to see if everybody's got the right kind of model.